David. Hey, everyone. As David mentioned, we are Productive Robotics. We are the only 7-axis, zero-programming, USA-made cobot on the market, and we manufacture cobots, which are designed to work safely alongside people at safe speeds. We're actually a bit different from fast-moving, big industrial robots, so keep that in mind. And a unique thing about us is we are made here in California, so hence the Made in the USA. Being founded in 2010 makes us the longest running collaborative robot manufacturer here in America. And we are able to automate all applications. And our usual customers are typically in the CNC machine tending and welding and fabrication, but we are always able to automate pretty much any and all applications. We also support fully integrated hardware and software. And another unique thing about us is we build our own gears, which a little bit later in this webinar, you'll hear a little bit more about that. Now, our main goal and mission is to automate anything in any shop, any application, all with ease. And what that means is there's not going to be cages that you typically see on these big industrial robots. There's no integrator needed. And better yet, there's no programming involved. And in this webinar, we'll show you all of that. You won't need any robot experience. Anyone can automate. And furthermore, being that we've been around for quite some time, we've had thousands of successful installations across various industries with various companies, and we are the leading American manufacturer of collaborative robots. Anywhere from small mom and pop shops to large enterprises, you name it, we've seen success with our cobots. So in today's webinar, we're going to show you how we automate older machines using our 7-axis cobot. We're going to show you a comparison between the 7-axis cobot we make versus your traditional 6-axis cobot and what that extra axis actually enables and why it matters. And of course, we're going to show you real-world applications across examples from CNC machine tending, welding, and general automation. And one of our welding engineers will also show you a live demo, a demo of the MIG welding we have. And then I will be showing you the live demo of the no code, no programming, and showcase that really anybody can automate with our systems. Now I'm going to go ahead and hand it over now to Rod, which is one of the inventors of OB7. So I think you'll have a lot to hear from him.
Hello, I'm Rod. Thanks, Brian. Let's take a minute to explain why we went with 7 axes on the OB7 robot. We envisioned the OB7 as a robot for laymen, designed to be easy to use technically and physically move naturally. The human arm is more akin to a 7-axis robot. The shoulder gives you 3 axes, your elbow gives you 1, your wrist gives you 3 more. So the OB7 has the ability to rotate the shoulder in a motion like this, which allows you to reach around obstacles and is not constricted to a vertical plane of operation like a 6-axis arm is. With only 6-axis, you'd be building a robot to operate machines designed for humans with an arm that moves less like a human. So we remove this handicap by adding the 7th axis. The human-like motion allows pretty much any machine designed to be operated by humans to be operated by OB7. Now, machine tending is a popular application for the OB7, and it's an area where a 7th axis is very useful. Reaching around the edge of a doorway into a machine is a primary benefit of having 7 axes. This means the robot itself can be stationed to the side of the entryway to the machine so that access inside the machine can be maintained. And if you need to get in there to change fixturing or do setups, you can do so without having to move the robot around. Cycle times between jobs improves. Fixture and tooling dependency also is due to the higher flexibility of the robot. The tooling can be pretty much the same as you would have when a person's doing the machine tending. So you have simpler fixtures, fewer custom brackets, and less time spent on engineering around a limited robotic movement. This is obviously a benefit for high mix shops who have long runs, short runs, and manual runs. The robot can kind of be a part of that whole scene and stay out of the way when it needs to be out of the way and get to work when it needs to get to work. And the 7th axis is the big part of what makes that happen. As your shop grows or your jobs change, the flexibility of 7 axes allows the robot to grow with you, and you can throw more work its way as your business grows. So here we have a little demonstration video showing a 6-axis arm trying to reach a fixture from the far side of an obstacle. In this case, the obstacle is a white column, but picture it as the edge of a doorway, for instance, in a machine. As the arm, you'll notice that as it rotates in to try and reach that fixture, this chuck that we have set up, it will come in and obviously not make it. So doing the same thing here with the 7-axis OB7 robot, it has the flexibility to get in there. Arms in this video are the same length. So this is strictly a matter of the flexibility at the elbow joint, at the shoulder joint rather, that allows it to achieve a pose that reaches the fixture. And so from here, let's see how this works in practice. Taking a look in our own shop, we're going to hand you over to Troy Kirby, who is our production manager and gear specialist. We manufacture all our own gearing in OB7, making it a very bulletproof arm. We developed the gearing to be manufactured, precise, and maintain its operational characteristics throughout the life of the arm. So there's no degradation as the arm gets older. Troy spearheaded the automation of the production using some older hobbing machines in our gear shop. So let's hand you over to our video of Troy in our own workshop, and let's take a look.
Let's take a quick break. I really want to show you something. This is our OB7 mounted to our 132 micron. Not only are we deburring our gears, we're also loading and unloading the micron now successfully. And we're running production. We've run thousands of parts for this machine now. So let me start the robot. We're using our standard part trays. We're re-gripping because of the tray, which is what that fixture's for. Puts it in configuration for loading. Pneumatic cylinder against the tailstock. Closes the door. And our I/O turns on the circuit to turn on the cycle of the machine. And now we're unloading. That's our blow-off kit. And places it back in the tray. This is our A33 micron. These are medium-sized part clusters. We're re-gripping like we did on the 132. We like to use our part trays. 4 different part numbers of similar configuration. This is our medium-sized cluster gears. Now it's going to load it into the spindle. Come back. Push the cycle start. All right, that's the A33 micron that we retrofitted. There's many machines in your shop that you can retrofit successfully with an OB7 cobot. Okay. Well, thank you for joining us. I'm Troy Kirby. As Rod mentioned, I'm the gear manufacturing manager. And we're very proud about the fact that we build our own gears in-house. I think we're the only manufacturer that does that. But what I like to do is I like to comment on the video first before I dive into some of our gear design, and really reflect on the fact that without having that extra axis, those moves that you just witnessed would be impossible. Both robots took us maybe a couple hours to play with, adjust, and actually start running parts once we had the tooling. We could reach things. You can see that the machines are mounted right on the hobbing machine itself. We did that on purpose so that we could actually access around the front of the machines, since we have quite a busy shop. We had to reach things, and so we were able to do that. You know, the one machine has a stretch so that we were able to reach around, and on the larger machine, the other machine is a standard OB7. But the moves that you saw, you know, it requires real wrist action, you know, forearm rotate action that, you know, we stand alone on that. And so we really love running our cobots on our old machines. And these are vintage old machines. That one machine is maybe 1965. The A33 is maybe in 1970 at newest. We're really proving that you can pretty much automate anything. We have proven that with that. So let's do a little dive into what I do for the company, which is manufacture the gears. So I have some samples sitting here that I just put out on the table just to kind of demonstrate the sizing. This is in the large joint carriage, medium joint, and then we have a small carriage for our small actuator. You'll notice there's a lot of gears in this. And what we have is we have a redundant gearbox. We're very proud of this design. I think Rod did a really good job initiating the design on this. Having two gears in mesh gives us full contact of 4 teeth at all times. This is a bulletproof, redundant gear drive. And it doesn't need servicing. Now that's amazing. It's a beautiful gear drive. So let's talk about the difference between our old gearbox design that we have and what the competition has. You know, my understanding is every other systems that are out there, cobots, use what's considered a harmonic style drive, maybe different variations. With my experience, the harmonic drives are lighter duty than ours. They require maintenance. Ours does not. Expensive maintenance is my understanding. And our system, you can run it for thousands of hours, hard use, without any issues. And I don't think too many other companies can say that about their cobot. So, needless to say, we're very proud of our gearbox and the materials and the manufacturing that goes into this. It's we use aerospace quality alloy. We actually achieve almost a ground quality on the gearing even with our old equipment. We actually finish polish the flanks and the profiles of the teeth. We use oversized bearings. All that being said, we have the quietest robot on the market and the most reliable robot on the market. So that being said, I think I'll hand it back over to Rod and Brian. Thank you.
Thank you, Troy. As he said, we are proud of our gearbox design. It maintains operational characteristics throughout the life of the robot. and does not degrade with time like other machines do. Let's get back to the applications of the OB7. In our next video here, we're going to look at a situation where we're tending 2 lathes with one OB7 robot. This application is loading and unloading parts, which is pretty standard stuff. This work cell has 2 lathes with only about 40 inches between them. So it's a tight little spot. Now the people didn't like working in this cramped environment. It was uncomfortable, a little bit dangerous, but the solution with our 7-axis arm allows the robot to reach in and achieve the part orientation to get into the chuck in each of these 2 machines equally easily for the 2 machines. So when they did this, the productivity went up 20%. The scrap parts went down. People weren't dropping them. The loading in the chuck was consistent and maintaining part quality. Operators were happier, lower injuries, etc. And delivery times improved with the company and this work cell. To quote their machine operator, it's that 7-axis that made all the difference. So here you can see the robot reaching in. The camera operator in this case is standing at a safe distance. And you can see they have regrip stations on the front of the machine, which are just a simple set of clips, which allow the parts to be swapped out and stand by for the next operation. And here we go to the other machine, and it's able to do the same without having to reposition the robot. And so this is a pretty standard work cell with 2 machines. This has been done in other places as well. And the OB7 makes it happen. This next example is more of a general case of a robot tending a CNC machine. In the case of a 7-axis OB7, shown on the left picture here in the slide, you can see the arm and its table and base are positioned to the left of the doorway of the machine. The 7th axis allows the robot to reach into the machine from this position. In the in the case of the 6-axis arm, the robot has to stand directly in front of the door to be able to reach the fixturing in the machine. And the overall footprint goes up because the arm is more limited in its movements. So you have a table and the robot directly in front of the machine, which makes getting into it to change fixturing and cleaning the machine, etc., more difficult. So because the OB7 can reach in from its position beside the doorway, you're not repositioning the cobot every time you switch jobs. And that saves time on setups, which any high mix shop can appreciate. So another situation that often comes up with CNC work is running a part through multiple operations. That can be a big part of why automation is beneficial. You can kind of simulate a 5-axis machine with a 3-axis machine if you are able to machine your part in multiple ops. The robot can automate this process so it becomes a single load operation as far as the human is concerned. The flexibility required to do that is more like what a person would normally be doing. A 6-axis arm would require more complicated fixturing between these ops, the regrip stations and whatnot, where the 7-axis arm can reach around the backside of a part to flip it over, etc. And in the stills that we have, op 1, op 2, op 3 here, this was a motor housing for a local company, and this was actually an assembly job, and it was able, the OB7 was able to do 3, actually this job, I remember it was 4 or 5 operations. This is 3 of those, and it was able to do them all without any, using pretty much their existing tooling for that whole job and the reorientation therein. All right. Lastly, we're going to look at a very growingly popular, increasingly popular application of cobots, and that is welding. And we're going to look at what the benefits that 7-axis arm gives you. So the advantages in the world of welding, anyone who's welded knows that the torch orientation is important. So you're following a path, you must maintain the angle of the torch to the path consistently throughout the weld. Because 7 axes gives you the flexibility to achieve a pose or position at the tool using more than one and only one robot pose, you have much more flexibility for the arm itself to avoid fixturing, to get inside of an internal cavity of a part. And these are things that a 6-axis arm may not be able to do, or would be able to do if you change the parts fixturing between multiple welds on the same part. All that translates into more time, more setup. And so if you can avoid that with a 7-axis arm, your arm actually, and your automation actually gives you a much greater benefit in the welding sphere. The extra maneuverability also allows you to automate a much larger range of parts. So parts that a 6-axis arm might not even be able to do now become automatable, if that's a word. So the list of parts that can't be automated gets smaller, and you become more effective in your automation. So here we have a video. I'm going to hand you over to Sam Gozart, and he's going to show you a quick demo of a 7-axis weld job. A simple little job here. So let's hand you over to Sam.
Hello, I'm Sam from Productive Robotics, and today we're going to be demonstrating the Blaze welding cobot system with its 7 degrees of motion, or 7 axes. The industry standard for welding systems is generally 6 degrees of motion, or 6 axes. Blaze has a 7th. When people hear that, they normally assume that it's found somewhere in the base or here on the end of the arm, when in actuality neither of those are the case. It's actually found here, in this arm right here. Notice that it's located before the primary 2 bending elbows. This allows those 2 elbows to reposition and orient themselves in all sorts of ways that a traditional 6-axis arm could not. To demonstrate that, we've got a large pipe here today. I've got it all mapped up, ready to go, and when I press go, pay close attention. This arm is going to get into position and then drop down on its side and enter the part. This is the key, this is the difference. A 6-axis arm would not be able to do that, especially entering a complicated or a large part to weld the interior or wrap around the far side. This is what sets Blaze apart. All right, I'm going to go ahead and press go. Feel free to watch. And there we have Blaze with its 7 degrees of motion.
All right.
All right. All right, everybody. Thanks, Sam, for that video. Thank you. Let's get it over. We're good? All right, great. So I'm going to go ahead and show you guys the zero programming feature and how easy it is to, number one, maneuver the cobot. I want to showcase the dexterity of it. And also just dive a little bit into the tile function that we have by just showcasing that now. So I'm going to pick up this aluminum block from one side, slide it to the other. How we typically do that is we utilize the handle. There's 4 buttons on each side. You just need to be holding down on one at all times to maneuver the cobot. And as you can see, as Troy mentioned earlier, our gears are super robust and super smooth, which is super nice. So I'm just going to go ahead and hover it right over the part where I want it to be. And make sure it's in a setting to go. And then on top of this handle, there's 3 functions here. There's a close, there's an open, and there's a waypoint. I'm just simply going to close down on the handle. It's going to give me a nice little vibration and a haptic feedback. Then I'm just going to pick up the handle, slide it over, nice and smooth, and I'm going to drop it down, let's say right around there. And within doing that on the handle, everything is now registered on our tablet here as 2 tiles. As you may be able to see, there's a pickup tile and then there's a place tile, which is super nice, organized. You can think of it as Lego blocks. And then all I'm going to do is click go, make sure my part is back to where it was initially. It's going to pick it up. It's going to glide it on over, nice and smooth. And then it's going to drop it down there. All right, so with that, now we're going to be jumping into our Q&A portion. And we would love to hear more about your guys' operations, what you guys have going on, what questions you guys have in your applications, and all in all, what you guys had in mind for automation.
All right. Well, thank you both, Rod and Brian. That was a great presentation. Really enjoyed seeing all the different videos there to putting the robot through its paces so we could really understand what you were talking about in the introduction. That was really helpful. One thing I want to note before we get started with the Q&A, I just want to remind the audience that if you have any questions for Rod or Brian and you haven't entered them into the webinar interface, now is the time to do so. But we have had a number of questions come in, so we'll get started with those. One of the first questions we've got is asking, how long does it take to get this robot up and running, and can their own internal folks handle that themselves?
Usually, depending on the experience and skill level of the people doing the work, it's a couple hours, as short as an hour, as long as a few hours if the customer needs to make fixturing or whatnot. A typical job can be accomplished by anyone who's a machinist level employee of your company. The robot does not require a robot person. It doesn't require an integrator. It's designed to be used by laymen. It's actually simpler than CNC or doing CAM or any of that kind of stuff. It's, as Brian demonstrated, it's point and click, and you just kind of guide the robot through the motions and make sure your fixturing is good and you're in business. So it's, a fraction of a day, let's say.
Yeah. And I can attest to that as well. When I first got started and got my hands on the first cobot, opening up the package and whatnot and setting it up with the team, it only took a couple hours. And me being on the non-engineering side, being a layman, I can attest to that. It takes probably about, a fraction of a day, as Rod mentioned. And that's typically what our customers also experience.
Okay, thanks for explaining that. This next question is asking, and it was shown in a lot of the videos, but it's a legitimate question since most 7-axis robots that we've seen on the market to date have been operating on the 7th axis is on a linear rail and not on the robot arm itself. But it's just asking, to kind of clarify the difference between how you approach the 7-axis robot versus a 6-axis robot on a linear rail. What's the big differences between those?
I would say that the 7-axis arm is a robotic arm. The arm in and of itself is a robot. The linear axis that some people use to mount an arm so that it can access a larger area of operation is generally independent of the arm. And we have integrated applications where that movement is actually part of the arm's kinematics so that synchronized motion is possible. So to answer the original question, the arm is 7 axes. The linear slide in our case would be the 8th axis. So you would have 8 total axes in that operation. So I know the industry tends to think of 7th axis is a linear platform of some sort. In our case, the 7th axis is the 3rd joint down the arm, which allows this motion. So a linear platform would be 8. Axis number 8.
I really like the welding video at the end there that really showed that articulation possibility there with the 7th axis on the arm itself.
Yeah, certainly allows movement.
Yep. One of the other questions we have here is wanting to know what are the limitations on part sizes that the robot can handle?
Part size is primarily limited by weight. The various arms in the OB7 family, there are 4 models. The payload ranges from 4 kilograms to 12 kilograms. And as far as part size goes, that becomes part of the fixturing. And part of the fixturing for a given part, especially if it's very small or large, is usually involves fabrication. A lot of people use 3D printers of the fingertips on the gripper. So if you have a tiny little part, you just make sure your fingertips can grab that part. The gripper that we offer, the PG2 parallel finger gripper, is very adaptable, and I've grabbed very tiny little pieces with it, and we've grabbed 8-foot long pieces of sheet metal with it just by extending fingers off of it, or making little tiny fingers. I even made one that can pour a beer for you, and it's all done with the PG2 gripper on the OB7 arm.
And I'll piggyback off of that as well. I actually think now we have a larger model. So our max payload, well, as Rod said, is our lowest payload is down to 4 kilograms, up to actually around 16 kilograms, if I'm not mistaken.
You are correct. Yeah.
So we have that. So from about 8 pounds to 35 pounds, and yeah, with that, people tend to forget that we are, based here in the U.S. So you're more than welcome to reach out to us. Tell us more about your application. You have Rod here to look over any applications or any questions if you want a more personalized look, which we do on a daily basis. So you always have the availability. And besides Rod, there's also a large team of engineers on site to help you vet your application.
This next question we got is asking about how you deal with backlash in the gearboxes.
Rod?
The gearbox and the gear drive in the OB7 is what we would classify as an anti-backlash system. It uses a redundant gearbox, as Troy mentioned earlier, of our own design, and it maintains its operational stiffness and its precise position ability throughout the life of the gearbox. Whereas most robots are zero backlash gearbox, and there is a distinction there. A zero backlash gearbox is precision manufactured, hand matched gearing that is subject to wear. They're the harmonic drives that Troy mentioned. They're beautiful little pieces of engineering, but in the real world, they do wear, and you will get a little bit of slop building up as those robots age. The OB7 maintains its operation accuracy and positional accuracy throughout its life.
We've got a two-part question here on this next one related to welding applications. The first part asks, can any welding power source be used? And the second part of it is asking about what communication protocols can be used.
You want to take that one?
Yeah, I'll take the first part of that question. So at this moment, majority of the power sources may be able to be used. We are partnered with Miller, so we do support majority of Miller power supplies. If you had a specific power source you wanted to look into, as I mentioned before, please feel free to reach out with a specific model number, make and model, and we can look into that and confirm that for you. You want to take that second part?
Yeah. The communication protocols are generally Ethernet based. We would work with you to assess the viability of the communication protocol. But again, anything Miller is readily integratable. We offer packages with Miller power supplies that use Ethernet communication.
Okay, and I know we talked a little bit earlier about any parts limitation would be really limited by its weight, and this one is more general, not just on the parts, but it's asking in general, what is the maximum weight that the cobots can lift?
35 pounds or 16 kilograms.
Okay. And another question regarding part, aside from weight, is there any maximum length and width of the part that are constraints on the robot's operation?
The constraints at that point become geometric. The workspace involved. We have picked up parts that are 6 feet long or 8 feet long, as long as the weight is enough. we can handle it. Of course, there's tooling in the end of arm that would be required to handle anything very big, but usually our stock gripper can handle it. We also have a linear rail system available, so if you have extremely long parts or an extremely long workspace that you want to work in, we can accommodate that.
Okay. We've got another one here wanting a little more information about the sensors used that act as like a safety mechanism in the cobots against any impacts with other components in the work cell, and of course, any interactions with humans around as well.
The OB7 is designed from the ground up to be a collaborative robot. It, at any given time, it knows exactly how much force it should be applying to achieve its current position or the motion, including the payload of what it's carrying. So if it experiences any external force, whether you're pushing in the direction of motion or against the direction of motion, the robot will stop, and it will stop its motion. It will give you a little red flag and require a restart, acknowledgement to continue operation. So it is safe from the ground up.
And also, I'll jump in and say, during that demo I just gave, it was in collaborative mode. It can run much faster with a waiver in place. Additionally, we do sell in our packages, if you would like, a LiDAR safety scanner, which is just a light, laser curtain, which is used if you want to use it at the higher speeds in your shop. So we do have also additional safety measures in place outside of the cobot.
So when you first get an OB7, it is in collaborative mode. And so anything you do with it will be intrinsically safe. Its speed and force are limited to industry standard collaborative limits. And again, if you want to go faster than that, you sign a waiver that acknowledges that you are going to integrate it properly in a safety rated work cell. And the robot will then be released to operate at its full, realizable speed.
Okay. This next question is kind of a follow-on to one of the videos that were shown earlier in the presentation, where the machining cell was fully automated in that, where all operations were handled by the robot. And this question is asking that if we do the same and fully automate our machining cell, does the cobot software integrate with most of the major lathe and mill brands to handle the opening and closing of the fixturing and machine doors?
It does. It's generally done either via an Ethernet protocol to send commands to and receive acknowledgement from the machine, or just simple M codes. So you have an MFIN cycle, and anyone in automation would know what that is, but essentially it's relay inputs and outputs to and from or between the robot and the machine. Generally a simple bit of wiring, and the interaction is pretty basic. We can also accommodate automatic or manual doors. The robot can physically open and close the door, and we can fit it with an automatic opener and closer if needed, if you want faster cycle times, for instance.
Same with the cycle start too, as well.
Yeah.
You can have the robot physically press the button, start and stop, or...
Yeah, we had an older machine in one of Troy's videos where the robot physically presses start, and that's a perfectly viable way to do this.
Okay. This next question is asking, can the cobot software be paired with quality inspection equipment to hold and inspect a completed part?
That integration is very much like a CNC machine. You would have signals between the machine and the robot. The robot would load the part in a fixture. The QC machine, like a CMM or similar equipment, would inspect the part and give the robot a go or no-go signal. And the robot would either put the part in the good bin or transfer it to the bad bin. So yeah, that is totally possible.
Okay. Got a question here. Want to know if 2 or more of your units can be programmed to work collaboratively together as a team cobot environment.
Yes, we have done that. The same signals that travel over Ethernet or over relays and wires can be used to synchronize one robot to another. In that one robot A does a certain task, signals robot B to follow up with its task. So yes, they can work as a team.
And then also, as you've seen in the video, the opposite is true, where one cobot can tend to two machines the exact same way, which is how a lot of our customers and shops boost their ROI right off the bat.
Here's a big one that always comes up in a collaborative robotics discussion is what's the stance on OSHA regarding your cobots not requiring safety cages?
That is the fact that our robots conform to ISO 10218. There are two parts to that safety standard, and that is the collaborative robot safety standard. We stay within those lines, and since we do so, the robot is rated safe per OSHA. So there will be no problems with that. That's a two-part standard. 10218-1 is the safety performance of the robot itself, and then 10218-2 is what the customer promises to adhere to when they sign that waiver if they want to go faster than collaborative speed. But in general, that is the safety standard that we follow, and so that satisfies OSHA.
Okay. And we've got a question here wanting to know about, is it possible to use these robot in food applications? So I'm assuming that goes into the hygienic applications around the use of these cobots.
The OB7s aren't rated for food contact. They can be utilized in a zone just outside food applications. So if you're actually handling food, you would need an end effector that is food rated. But the robot itself is not rated for operation in contact with food.
Which piggybacking off of that, third-party end effectors, any end effectors you guys are currently working with, OB7 does integrate really well with other end effectors and accessories. So keep that in mind as well.
Yeah, it's an industry standard flange on the end of the robot. You can mount pretty much anything to.
Okay. And I think this one is referring to Brian's demonstration near the end where you're moving the robot through the basic waypoints. And it's asking that once those rough waypoint moves are programmed, is there a way to then further optimize those motions?
Yeah, so I set pretty much a pickup and a place point. You are able to utilize the waypoints to kind of optimize that motion if you'd like. You can also jump into the tablet where those tile functions were and also further optimize or get into more detail on your precision points there.
Yeah, the tablet allows you to, once you've established a movement or a pick and place operation, you can go back through it and run it at slow speed to make sure you're clearing any obstacles and make sure the move is looking exactly what you want to do. The tablet acts as kind of a digital joystick, as does the robot itself. You grab its handle and move it around. So you can jog the robot to a specific point in your program and then kind of adjust its position a little bit and redefine that waypoint. All the moves of the OB7 are defined by points in space. So if you're moving from here to here, you can establish a point up here if you need to avoid an obstacle somewhere along the way. And it just kind of connects the dots when it moves in a smooth manner.
Also, since we were kind of beholden to time on this webinar, if you wanted, of course, a personalized demo, you're more than welcome to reach back out, and then we can dive way deeper into, number one, that digital joystick tablet that we mentioned, the jog control screen page, and just go through in depth what we are talking about here as we're speaking about it in a nutshell.
All right. And with that mention of time there, Brian, I see looking at the clock here, we've pretty much run out of time here for this webinar. So I'd like to thank you again, Rod and Brian, and all of the attendees for watching and the great questions we received. And on behalf of Automation World, I'd like to thank Productive Robotics for sponsoring today's event. And again, of course, all of you for joining and making it a great event. If you'd like more information from Productive Robotics, scan the QR code on the screen, or you can follow up with them directly using the other contact details shown. And before you go, please take our exit survey at the conclusion of this broadcast. Thank you.
Thanks, guys.
Thanks for joining us.